Because I like this class a lot, I've given you a bonus example for us to do. Now, this isn't anywhere in your book. This is only out of my head, hence why it's the j of x one more time. The first thing we want to do is we want to expand this out, because remember, expanded form also tells us some great information. So I'm going to expand the denominator first. Our numerator stays the same. That part isn't changing one iota. Still have 3x minus 4 times 6x plus 8. The denominator, when we break it down, becomes x minus 1 times x plus 1. All right, so there's value in that piece. There's also value in going back to the original form, keeping the denominator the same, x squared minus 1, and expanding the numerator. So you've got 3x times 6x, that's 18x squared. You've got 3x times 8, it's going to be plus 24x. You've got negative 4 times 6x, that's going to be minus 24x. Those are going to cancel out. And finally, we have negative 4 times positive 8, that's negative 32. So it looks like then that our other expanded form is going to be 18x squared minus 32 over x squared minus 1. And there's value in doing this. It's not just an exercise in futility. There is value in expanding and contracting things so that we get different alternate forms. Those forms will tell us information. Let's run our steps. Step number 1 here, bottom left-hand corner. Our vertical asymptote happens where the denominator equals 0. We're going to use this form right here, the second form we came up with. It shows that x minus 1 times x plus 1 is our denominator. So we're going to say that x minus 1 is equal to 0 and x plus 1 is equal to 0. This tells us that x is 1. This tells us that x is negative 1. So we just found two vertical asymptotes. Something we haven't seen just yet in our problems is two vertical asymptotes. It's one of the reasons why I picked this one, because I wanted us to see an example that had two vertical asymptotes. Okay, the horizontal asymptote is next, the ha. For the ha, remember we pick out the item from the numerator that has the biggest power. So our last one that we came up with has that. I see 18x squared, so I'm going to use that as my numerator value, 18x squared. My denominator has just x squared. And this is good too because they have the same power. 18x squared and x squared have the same power, and so we cross those values off, and what's left over is 18 over 1, otherwise known as 18. So our horizontal asymptote is something called y equals 18, much like our vertical asymptotes are x equals. So we should formally call this y equals 18 to make sure we have it down the correct way. Step number 3 is the y-intercept. What happens when x is equal to 0? And again, we can use the last form we came up with. That would show us we have negative 32 in the numerator when x is 0, and we have negative 1 in the denominator when x is 0. And that tells us we're going to have a grand total of positive 32 then is our y-intercept. Remember, we want to write that as 0, 32. Step number 4 is the x-intercept. With the x-intercept, we can go back to the original form here, the very top one. It shows our numerator was one parenthesis times another parenthesis, and we want to set that equal to 0. In other words, 3x minus 4 times 6x plus 8 equals 0. This means that 3x minus 4 is 0, and that 6x plus 8 is 0. This one says that 3x equals positive 4. This one says that 6x equals negative 8. We're going to divide both sides by 3 here and 6 on the other one. Looks like we're going to have the same answer both ways, one positive and one negative. So x is going to be plus or minus 4/3. Or for us, that means our x-intercepts are going to be positive 4/3, 0, and negative 4/3, 0. This one's rocking and rolling along. All right. Step number 5, the Achilles point. Let's do that towards the middle here. And we're going to take a form of our function and set it equal to our horizontal asymptote here of 18. I say let's use the form that's right next to 5 because it's got everything laid out for us already. So we're going to take 18x squared minus 32 divided by x squared minus 1. And we're going to set that equal to 18. We're going to see if this solves. Remember, if it does solve, it has an Achilles point, it has a weak point at this x value. So let's cross multiply here. This is 18 over 1. Cross multiply the top, that's going to give us 18x squared minus 32. And if we cross multiply the bottom, we're going to get 18x squared minus 18. All right, this isn't going to solve for us. That's great, because if we move either 18x squared over, they're going to cancel out. We're going to have 18x squared minus 18x squared. It doesn't matter which number it is over here because these two cancel out and give us 0x squared. So it does not have an Achilles point. Let's put a no here to remind us of that. And we're ready to rock and roll. So now let's put the graph down and be done with this problem. Start with the vertical asymptotes at +1 and -1. So here's +1 and here is -1, and we're going to have dashed lines that run through these points. For the negative and for the positive. Good, we got that down. Next, the horizontal asymptote. So somewhere here is about 18. Let's put a label on it. And again, is an asymptote, so it's a dashed line that runs through 18. Next comes our y-intercept at 32. Somewhere up here is going to be a point. That point is 32. We've got that. Next comes our x-intercepts at 4/3 and -4/3. So 1 1/3 and -1 1/3. So one of them is going to be right about there. There's -1 1/3 or -4/3. And here's the other one, +4/3 here. Let's go ahead and label that so we have them. Now labeling never hurts. So we've got that, and that's all she wrote. So now let's put it together. So we have a section that is left of -1, left of the vertical asymptote here. And in this section, our graph is above or below the horizontal asymptote. Because there's a point here, obviously it has to be below. It can't be above if there's a point in the space. So we'll draw this one. Same looks like it's going to happen on the other side here. We got +4/3, and again, it's above or below the horizontal asymptote. However, because there's a point, it has to be in the space. So it's going to follow this horizontal asymptote, and then it's going to come down through 4/3 and follow the vertical asymptote. Make sure you put arrows, very important. And now we have the horizontal asymptote, the middle section here between the two verticals, which is a section. And it's either above or below this horizontal asymptote. Well, two things tell me that it's above. One, there's a point at 32, and two, there are no points on the x-intercept. So more than likely, this is going to be something like this, kind of a parabolic shape in between the two asymptotes here. It's not perfect. You know, if you were to graph this on a graphing calculator, it's going to give you a slightly different answer because it's going to do it perfectly. I don't expect perfectly. I don't want you to use your graphing calculator. I want you to use your brain to do this. You know, sometimes in the past, people have accused me of graphing Batman, given my affinity for the Dark Knight. And I say, how? And they say, well, there's a wing to the left and a wing to the right, and this is kind of like his cowl. It's kind of a stretch for me. I don't think that that's graphing Batman, but I'll let you make that choice.